All right, hopefully people can hear me okay. We'll begin in just a second. Testing, 1, 2. All right, I'll wait and see if anybody shows up here. All right, looks like I can see myself. Looks like people are joining. That's great. We will begin in just a moment. Take another drink. All right. I think we're ready to begin. So welcome to the second live lecture and the first virtual office hours for the mobile communication programming course. As those of you who've been taking the other MOOCs with me know, this is where we get together and go over solutions to programming assignments, show some other examples. Sometimes we show some slides. We won't be showing any slides today. And of course, I'm always happy to take any questions people have about any of the topics that we've covered in the class, any of the topics we will cover, and of course, anything having to do with the programming assignments that we're going to be doing. As most of you probably know by now, the first programming assignment is up, and it's been on GitHub for a couple of days. It's also now released to the peer assessments page, so you might want to go check that out. I posted some information about that earlier today, and so that's where you can go and find out more information about the first programming assignment. We'll cover the skeletons for the first programming assignment today, and next week, early in the week, we'll also walk through another example that is somewhat similar to the one that we're doing as the first programming assignment. So that'll give you a better idea of how to go about solving the particular assignment problem that we've put forth. Before we go through the programming assignment skeleton, however, the first thing I want to do is walk through another example. This is one that illustrates in a little bit simpler way how to go about designing and implementing and accessing content providers. And this will give us a chance to talk about a bunch of different kinds of things. Okay, so without further ado, let me go ahead and share my screen. So what you're looking at now is my Emacs window. Let me make the font a little bigger so it's easier to see. The programming assignment that or rather not the assignment, the example that we're going to talk about here comes from the course website. And if you take a look at the announcement I posted this morning, it gives the link as to where to find this particular example. This example is kind of whimsical at some level, but it illustrates the canonical way to implement and access content providers. And it also shows a bunch of other cool things along the way. Here's a quick summary of what's in the manifest file. We have a single activity called the Hobbit Activity. You'll see why it's called the Hobbit Activity in a second. And we have a single content provider called Hobbit Content Provider. And this content provider is not actually exported. So it's private to this application. But if for some strange reason we ever wanted to let other applications use it, we could go ahead and make it be exported true. You'll notice also that this content provider runs in the same address space as the activity, but that would be easy. If we wanted to change that, we'd simply say Android process equal, and then say, you know, my process, or whatever we wanted to call it. So that's how we could do that, but we're not going to do that in this particular case because we aren't trying to show that point. But it's easy to make things be shared. You typically wouldn't run a content provider in its own process unless you wanted to share it with other applications. Let's go ahead and look at the source code. The source code follows our sort of canonical structure. One of the key themes I'm trying to convey through all these examples is that writing good Android applications is not just a matter of knowing the Android APIs and the frameworks and class libraries. It's also about structuring things in a way that makes it easy to understand, extend, change, and so on. And so we have 4 main packages. We have the activities package, which is where the user-facing operations go. We have our operations package, which is where we actually implement the core of the business logic. We have the provider package, which is where we're going to implement the content provider and associated helper classes. And then we have the utils directory, which are just a set of useful classes that find their way over and over again in the examples we do. This example, as you can see, is going to use the generic activity framework. We've talked about that before. The lifecycle logging activity, we've talked about that before. The retain fragment manager to hold the state of the ops object consistently across configuration changes, and then configurable ops, which is also part of the generic activity framework. So let's first go look at the activity. This will give you a sense of what it is we're actually doing with the content provider, and you'll get a better sense of how the application actually is structured. Keep in mind, of course, there's lots of different ways to do this. This is just sort of the way I tend to gravitate towards, but naturally you're free to do it different ways. This activity illustrates how to use the Hobbit content provider to perform various CRUD activities, which are basically create or insert, read or query, update and delete operations, using characters from J.R.R. Tolkien's classic book, The Hobbit. And I'm a big Lord of the Rings and Hobbit fan, and so you'll find examples popping in various times. All right, so Hobbit Activity is a generic activity, and it's going to have the Hobbit ops be the main operations object. We have a list view, which we're going to use to display the Hobbit character information. We have the onCreateHook method, which sets the content view for the activity, initializes the list view, and then calls up to the generic activities onCreate method, passing in the class that we want instantiated to be the operations class. That, as you know, will be used by the generic activity framework to be able to handle rotations automatically, so that there's very little work that's done in the application for that. And then down here, we actually have the main workhorse method, which is called run. And if you compile and execute this program in Eclipse, which you can certainly do because you have the source code, you'll see there's just a single button called run. You click the button, and all the stuff that I'm about to show you takes place. So the first thing we do is we insert a bunch of characters from the Hobbit into our content provider, and we put in the character's name and their race. So we insert Bilbo, who's a Hobbit. We insert Gandalf, who's a Maya, which is basically a sort of a lower god in the pantheon of characters, the theology of Tolkien. And then we insert a bunch of dwarves. If you're a Tolkien's fan, you know that the Hobbit has a bunch of dwarves. I think they're 12 dwarves or so. And we are actually 13 dwarves, I take it back. And we go ahead and we insert them and their dwarves. We insert the dragon, Smaug. We insert Bjorn, who's initially a man. And we insert Necromancer, who's also a Maya, which is basically like this demigod. And then, of course, we're going to do some updates. So we're going to update by name. We're going to change Bjorn's race to a skin changer because he's actually able to change into a beast. I guess we should really call him a bear because he becomes a bear. And we're going to update the Necromancer by his URI because the necromancer, of course, really is Sauron. And you can see here that when we call insert, we get back a URI for that particular row in the table. And so we can go ahead and update by that row. So that'll change that row, update it. A bunch of dwarves get killed in the Battle of the Five Armies, so we get rid of them. We delete them by their name. The Smog, the dragon, gets killed by Bard the Bowman, so we delete by race. We get rid of all the dragons. And then we go ahead and we display the results. And you can see here that we're going to display them by their race. And we're going to give a group of different races here. Okay. So that's basically sort of how the program works. And the last thing we do is we close down our ops object. Here's a display cursor method that simply goes ahead and sets the adapter appropriately. All right, so that's basically the activity. Pretty straightforward. You can see, of course, the set of CRUD operations here, and they're doing all the various interesting things that we come to expect. All right, let's go over and take a look at the operations now, and we'll see what they're doing. Before we do that, though, I seem to be having some technical difficulties on my end. Let's see, hopefully nobody else is experiencing this. All right, I think it's going live. Good. Oh, we left out Aragon. Well, that's a good question. Didn't have time to put everybody in there, but since the source code is available, people are welcome to come along and add them as well. So, of course, I should also point out that Aragon is not actually in the Hobbit, so he's in the Lord of the Rings. That's why we left him out. These are characters from the from the Hobbit book. Okay, so here's the Hobbit Ops class. This class is kind of fun because it implements configurable ops, so we can have it managed by the generic activity framework, but it also plays a bunch of other roles and other patterns. It plays the role of the abstraction in the bridge pattern, and you'll see how this whole thing plays out here in a second. We do this for some pretty cool reasons, as you'll see here. We're going to basically use this class to be the abstraction that will then delegate to the appropriate implementation hierarchy. And that implementation hierarchy will allow us to choose between using a content resolver versus a content provider client to actually access the contents of the Hobbit content provider. And I'll talk a bit more about the differences between these two things as we go along. Here's the access means object, which is essentially going to be it's an enumerated type. It's going to use the content resolver by default. We'll show you later how to change that. Here's the implementation object. If you read the bridge pattern, this is the impl pointer that is part of the bridge pattern, and that's going to point to a Hobbit's ops impl object, which will be dynamically created here in the constructor. The constructor takes a look at the access means and then creates the appropriate implementation class, either the Hobbit Ops Content Resolver or the Hobbit Ops Content Provider Client. And you'll see how this gets used shortly. The long and the short of it is that Android has a couple of different ways to access content providers. One is to use Content Resolver, which is the most common way. But every time you call an operation like insert or delete on a content resolver, it has to go ahead and revalidate the authority and access the content provider, and that takes some extra steps. So Android provides an optimized path called the content provider client, and that's quite a bit faster to access, but it's more limited because you can only call it in one thread. It keeps thread-specific storage or thread local storage. So it's more limited, but it's more optimized. So rather than trying to have two different implementations, we're going to have one implementation and then select between them using the bridge pattern. Unfortunately, the Android has no common framework or common interface to treat these things in the same way. So we're going to use something called the external polymorphism pattern to wrap polymorphism around two classes that are otherwise not related by inheritance or interfaces, so we can treat them in a common way. Okay, here is the on configuration hook method. this is part of the generic activity framework, and this gets called back every time an activity is created or recreated as a result of runtime configuration changes. And you can basically think of this as sort of a virtual constructor, and so it's going to handle the initialization operations. All this thing does is just forwards to the implementations on configuration hook. I should also point out, by the way, that the onCreate method that was called over here in Hobbit Activity, this is actually coming out of the generic activity framework, which we talked about in the last lectures that I did. If you take a look at the lecture where we went through the contacts content provider simple example, I talked about what the generic activity framework is. So go back and watch that video if you're curious about it. But basically, it defines an onCreate method that passes in a class object that's used as a factory to manufacture instances of that class. So that's where that's coming from. If you need more information about that, go back and watch the earlier video from last Wednesday, or this Wednesday, which is on the contacts content provider simple example, and that talks about how this all works. Okay, so we then have a close method which forwards to the impl close. This is just the good old bridge pattern. And then we have a whole bunch of methods here. We have insert, bulk insert, update by URI, update by name, delete by name, delete by race, display, et cetera, and notice how every one of these methods simply forwards to the implementation of this particular interface class, or abstraction class, as they call it in the Gang of Four bridge pattern. All right, so that's actually what the application accesses. So the Hobbit activity accesses everything through Hobbit Ops, which is an abstraction, and it basically forwards all of the method calls to the implementation. Here's the Hobbit Ops impl class. This is an abstract class. And this class, again, plays a number of roles and patterns. It's the role of the implementer in the bridge pattern. It's the role of the abstract class in the template method pattern. And it also is an example of this thing called the external polymorphism pattern. If you Google external polymorphism, you'll find a pattern I wrote many years ago talking about how to add polymorphic behavior to non-polymorphic classes. And that's basically what we're doing here. So this class contains the reference to a weak reference to the activity, the Hobbit activity, so we can interact with it when we need its context for various things. We keep track of a cursor, which we're going to use to redisplay the results after runtime configuration changes. This is very canonical. Here's the hook method that's called back when we either create or recreate an activity. And as you can see here, this stashes away the reference, weak reference to the activity. We need that so the garbage collection works properly. And if this is not the first time in and there's a cursor, then we go ahead and we display the cursor. So that's how we handle rotations very cleanly. By default, close is a no-op. Subclasses can override this. We'll see how we have to use that for the content provider client. Now, here's where things get fun. This is this method here. This is the insert method that inserts characters and races into the Hobbit content provider. And as you'll see here, it uses the template method pattern to separate accessing or creating things that are going to go into the database from actually the means by which we access the database. And you'll see why we do that in a second. So here we basically have content values object created. Content values are how you pass information that's going to be stored in some kind of a database or map. Then we go ahead and we put the character into the content values by its column name. I'll talk more about that later. And then we go ahead and put the race of the character into the content values by the column race. I'll talk about that later as well. So those things go into the content values. And then we call up to the hook method called insert, which will then delegate to the subclass to figure out how to actually do the insertion. And that way we separate out the data that we want to insert from the means by which it gets inserted. And that, of course, is going to insert it at the content URI that we actually care about to access the map or table that forms the actual storage that we're doing. So that's insert. Then the abstract insert, this plays the role of the abstract hook method and the template method pattern. This, of course, will be filled in by a subclass. Bulk insert, kind of a fun example here. Bulk insert, as I mentioned before, when we talked about the contacts content provider simple application, is a way to insert multiple rows into a table in one fell swoop, in one operation. And so what we do here is we take an array of characters of a particular race, like a bunch of hobbits, or a bunch of dwarves, for that matter, and we go ahead and we create ourselves an array of content values. And then for every element that we have in our array of characters, we create a new content values object, put the appropriate character and their race into that element, and then we insert that into the array. And after we've inserted everybody into the array, we go ahead and do a bulk insert, storing them at the table with the array of elements. And we'll see when we look at the content provider implementation how that all works. And of course, there's also a bulk insert abstract method, which is used with the template method pattern. Query, we'll see query is used in a slightly different way than the other methods, but we basically just have an abstract hook method for that. We have update by URI, which does updates. You can see how that works. And we're going to update things by their column name, and you'll see how that gets used. You can also, so this is an update by URI. This will update, you give it a specific row in the table you want updated, and it'll update that if it matches properly. And then we do update by name, where we go ahead and update things in the entire table. In this example, we just update one thing, but you could update many things. Here's the update hook method, abstract hook method. We'll look at that in a second. And here's delete by name. You can delete things by name. And this will do it by the column name as the selection criteria. And you can actually have a list of character names you want to delete, like a bunch of dead dwarves. And you can also delete by race if you want to. So in this case, we're going to select the race as the selection criteria. And you can have a set of races that you want to delete as well. And we'll go ahead and delete all of them from the table. And here's the abstract delete method. And then finally, here is the way we display things. When we display something, we indicate what selection we want to make. For example, we can delete by name, we can delete by race, etc. And then depending on whether we're deleting by name or race, we can go ahead and give a list of names that correspond to the names of the race. And of course, you can leave those things null, in which case it'll just query the entire table. When we get the cursor back, we stash it away so it can be redisplayed. And then we call display cursor, calling make cursor adapter. And make cursor adapter simply makes a simple cursor adapter with the cursor and the activities context. And that's then used to display the results in a tabular form, in a list view-like form. Okay, so that's basically how we are going to, that's the common behavior using the template method pattern and the bridge pattern to do the work. Now that we've shown that, let's go ahead and take a look at a couple of different implementations. We'll look at the content resolver implementation first. So not surprisingly, the content resolver implementation extends Hobbit Op Simple using the bridge pattern-like model. And it defines a content resolver as a field. The onConfiguration method, when it's called, first calls up to the superclass, which redisplays things if it needs to. And then, if this is the first time in, we go ahead and we will create a content resolver and stash it away in this local field. So now we've got a content resolver. Here's the insert method. This is the concrete hook method and the template method pattern. You can see all this thing does is it just takes the results that are passed to it as parameters, and it actually uses the content resolver to insert them into the content provider. And so all these methods are really just forwarding to the appropriate methods in the content provider, and they're using the content resolver as the means to access that. Here is the content provider client version of this. It's almost identical, except it uses a content provider client as opposed to a content resolver. Its first time in flag needs to go ahead and do two things. It first gets the content resolver, just like the other one did, and then it goes ahead and it gets the content provider client from the content resolver, because that's a more optimized path. It's an optimized proxy that doesn't have to go through as many lookups to access the contents of the database or of the content provider. So it stashes that away. You actually have to release the content provider client when you're done with it, so that's what the close method does. And then insert, bulk insert, query, update, delete, they simply forward to the appropriate content provider client methods, which themselves have an optimized path to accessing the content provider. Okay, so that's basically the accessing means to all this stuff. That's how we access it. And it's just kind of showing you how to use a couple of patterns like bridge and template method and external polymorphism and so on to make it easy to switch between different optimization paths through the code. The real interesting part here for the example that we're discussing is not the client. We need to talk about the activity and the ops class just so that you understand how it works. The really key part I want to focus on here is the part that relates to the content provider. And the way I'm showing you how to do it is very canonicalized. Your programming assignment does it basically the same way. So the common way of doing things is to define something called a contract class. And that's the class that defines the metadata that's used by the content provider. And it includes various ways to access the provider and various constants and column names and so on. And this is the very common way you see things done all the time in the Android source code. The first thing we do is we provide our content authority, which in this case is Vandy MOOC Hobbit Content Provider. You just need some kind of unique name. So this can be represented in a consistent, unique way across the different parts of the platform of the device. We then use this content authority to create a base content URI. You'll see how that gets used a little bit later. And so basically, what you'll see here is we have add the content flag, and we add the content authority to that, and that makes the base content URI. We'll see how that gets used later. Then we create something called a path character that gets used a little bit later. That actually defines the map, the path to the map. And you'll see that the map, in this case, the backing store for this particular implementation uses a hash map. I'll extend this shortly to use an SQLite database. That would be the more common way of doing things. The key point here is it doesn't really matter where things get stored. Here's the base columns table, and the base columns or actually the character entry, it implements base columns interface, and this defines some of the column names we're going to use in our table actually it's the Hobbit table, not the acronym table. And it's actually a map, hash map. I think I'll call it table because I'm going to change that later. Here's the content URI. This is actually the way that we reference these things. As you can see, the content URI takes the base content URI and appends the path character to it. So now we've got a way to actually access the table name. So the content URI is a way to access the table or the implementation data structure. There's a couple of MIME type fields we define here. We define content type and content item type. This one corresponds to when we want to identify all the items in the table versus just one item in the table. Here's the name of the map or the database table, which is a map in this case. We call it character map. And then we go ahead and define a couple of helpful constants. Selection character, we can select things by a column name. And this is a wildcard character that's filled in with the actual name we're looking for, like a character's name, for example. Here are the columns. We have the name column and we have the race column. And those are the two columns, two of the columns in our database, along with the ID column, which is defined by inheriting from base columns. Okay, and then the last thing we have here is just a helper method that builds a URI that includes an ID at the end. So that's how you would actually build the URI that had the content URI plus the ID that indicates a specific row in the table. When we talk about the shells for the programming assignment, you'll see that they have a character, they have a contract file very, very much like this. It's a little bit more sophisticated, but it basically has the same idea. You want to get in the habit of putting this kind of metadata in a contract file. It's a good place to put it. Okay, here's the actual record structure we're going to use. Of course, in real life, we would be probably using SQLite, in which case you would define a table as a string. This is just a character record, plays the same purpose. For our simple example here, we have the ID of the character in the map, we have the name of the character, and the race of the character, and we have a bunch of constructors that create things accordingly, and we have some accessors to get the information out of there. All right, and now the final part of this, the real fun part, this is where we define the content provider itself. Hobbit Content Provider is a content provider. We define ourselves a little tag to use for debugging. We define a couple of constants that we use in order to differentiate between requests for an entire, all the characters in the table versus a single character in the table. And you'll see how this gets used in a second. We then make something that's called a static URI matcher. This is always done in Android content providers. This is how it's a little pattern or an idiom they use in Android to quickly identify whether you're asking for an individual element in a table or all the elements in the table. And we initialize this by calling build URI matcher. Here is build URI matcher. It goes ahead and makes a matcher, gives it a no match field by default, and then it goes ahead and it creates a URI that uses the content authority, which is basically the field that's defined here, Andy MOOC Hobbit Content Provider, the path character, so path character, which is basically the map name. You look at map name, you'll see it's character map, and then the code, either characters or character. And notice if you give this funny string constant, that says this thing is going to have, that this represents an individual element, whereas this represents an entire table. So that's the URI matcher. We go ahead and initialize that here. We're going to use this all over the place in just a second. We define our columns. We use the columns in our table. We have the ID, which is provided by the base columns. We have the column name and the column race, which are defined in the contracts entry. And then we have the type information. And we need the type information when we make the simple cursor adapter to display all this stuff. So we have the ID, which is a string, the name, and the race. And that's an array of integers. Now have our implementation backing store, if you will. This, of course, is just for fun. I use a hash map in this implementation. Next time when we revisit this, we'll use SQLite. I'm trying to illustrate two things here by using a hash map. Number one, a content provider doesn't have to use SQLite if you don't want it to. That's very common if you want persistent storage, but you can also make content providers that use other means to store things like hash maps or flat files or calls to the network, whatever you want. So the content provider abstracts away from the details of how things are stored. And I also wanted to have some fun just sort of implementing very simple operations to teach myself more about what's actually going on under the hood when you use this stuff. So we use a hash map, and I'll show you how that works in a second. There's a get type method that's used that takes a URI and indicates whether it's either singular or multiple types that were being requested. This illustrates the use of the URI matcher, which takes the URI and then determines whether or not this thing is a one or many. Let's see. So that's kind of the canonical way that you do things. Let's now start taking a look at the methods. So here's the insert method. So the insert method comes in and goes ahead and matches the URI and tries to decide what kind of an insert you're doing. In this case, we're only allowing inserts that insert records into the entire table. That's common. If you're given a specific row, it throws an unsupported operation exception. Here is the implementation of this particular thing, and again, there's lots and lots of different ways to do this. One thing I do here is, because I'm using a hash map, I have to go ahead and provide synchronization, because by default methods in a content provider like insert, delete, and so on are not synchronized, so we have to synchronize them ourselves. And I chose this particular approach for reasons that'll become more clear when we actually get to the point of talking about the bulk insert. So if the map contains the key that we're looking for, so then we go ahead and make a new record, and we take the content values that we have here, and we use them to extract the column name and the column race. We put that into the column, the character record, and then we go ahead and we insert the character record into the map by its ID. And then we go ahead and we take this ID and we create a URI with that ID appended at the end, and that becomes the return value that we're going to give back from this particular method, from the insert method. And then the last thing we do is we notify registered observers that a row was inserted. We don't use the notify change mechanism here, but we could have, and it's a good idea to get in the habit of doing this as a courtesy so that things can be notified if the database changes. So that's insert, that's inserting one element, and you saw how we used that earlier. We inserted, like, Bilbo is a hobbit. There's also a bulk insert operation, and that's for inserting groups of things, like you can insert groups of dwarves, for example. And notice that what we do here is we synchronize the entire section where we're inserting these new elements. So this will be essentially an atomic insert. We're going to insert all these things into the table in one fell swoop, and we lock access to the table while we're doing this. What we do is we iterate through the array of characters, and we put each one of them into the table. And I should probably refactor this code a little bit so it's a little cleaner, but you get the basic idea. And after we've inserted all these things, we keep track of the number of inserts we make. We notify the observer that the rows were inserted, and we return the count of things that happened. Here is query. Query is kind of fun because we can query both for the entire table as well as an individual element in the table. So based on the match that we get, we're either going to query the whole table, in which case we go ahead and iterate through all the elements in the table, and we build the cursor conditionally. I'll show you what this method does in a second. Or if we just query for a single character, we go ahead and grab the ID from this character. We go look that character up in the map, and then we go ahead and build a cursor if that character matches the selection criteria that were passed in here. Here is the build cursor conditionally implementation. This is not really all that relevant unless you're really curious about how to fake some of the operations that you would do with an SQL database. But we basically go through all the selection args and see if things match, and if they match, we go ahead and add the item. We add the element into the cursor. Here's an update. Update also works both on the entire table as well as just a single character that we're trying to update. And so if it's on the entire table, we iterate through the table, and we're going to go ahead and update the entry conditionally. You'll see how that works. Otherwise, if it's a single element, we're going to go ahead and update one element. And updating basically works much the same way that we did for querying. We go through here and check to see whether there's a match, and if so, we update the record that's in the table. Here's delete. Delete also works both for the entire table as well as an individual row in the table. We switch on the result of the URI matcher, and then we iterate through the table and delete the entries that match the selection criteria. And we either do that individually, or we do it for every element in the table, or we do it for one row in the table. And if we actually ended up deleting anything, we notify any observers that stuff has changed. And here's how you delete stuff conditionally. So that's basically a quick tour through this code. Again, you would very rarely use a hash map to implement a content provider. I'm just doing this so I don't have to explain a lot of details yet about SQLite. We're going to talk about SQLite on Monday and I'll give you some examples. We'll come back and revisit this example using SQLite. Okay, so that's basically an overview of the first example, which will hopefully give you a feel for how you implement content providers in a canonicalized way. And then shortly, we'll go ahead and look and see how you will have to do this for the first programming assignment. There's a bunch of questions, though. Let's take some questions. Is a content provider required only when data has to be shared across multiple applications? The answer to that is absolutely not. Content providers are used for all kinds of other purposes as well. The content providers are basically used anytime, almost used all the time in Android when you want structured access, especially to persistent data. There's some nice discussions on the discussion forum that go into this in more detail. Someone asked a good question about using ORM versus using content providers. And the long and the short of it is that you use content providers for a whole bunch of other things besides making your data accessible to other applications. You can use content providers if you want to have notified content observers be notified automatically when things change in a table. You can use content providers when you want to use things like sync adapters. Basically, almost every application in Android that's interesting uses content providers. So it's a canonicalized pattern that's reified in a framework for accessing typically persistent data. And so if you read the Android source code, you'll see all kinds of examples. Oh, great question here. Could we have used a concurrent hash map instead of a hash map and removed the synchronized blocks? Steve, I started that way originally. I started off by using concurrent hash map because it's very cool. And then I ran into a glitch. And the glitch was that the bulk insert operation needs to be able to lock the entire table to insert all the items atomically. Now, if you were using SQLite, you would use begin transaction and end transaction on the database to do this same kind of thing. But there's no method on a concurrent hash map that lets you lock the entire table. So because of that, I fell back and used just a good old synchronized statement to give me the degree of synchronization control I needed to provide the semantics I wanted for bulk insert. So yeah, I thought originally I could get by with using concurrent hash map, but I couldn't. But that's a good question. Your intuition was in the right place. Let's see. Do you think content providers are a leaky abstraction? I feel like parameters such as the selection args can leak implementation details. Daniel, absolutely yes. I couldn't agree with you more. Using SQLite and content providers is definitely leaky. I tried in my implementation here to abstract away from it to some extent. But as you saw, I only achieved a partial abstraction because I didn't want to kill myself implementing a full-blown SQL query parser and semantics for my simple hash map based implementation. So yes, it is definitely a leaky abstraction. In my experience with Android thus far, dealing with data and persistent data is by far the most tedious aspect of writing applications in Android. It is just unbelievably mind-numbingly boring. And there are certainly much better ways to do things, and we'll probably talk about some of them in this MOOC. But if you get too far afield from the basic content provider SQLite mechanisms, then you'll be swimming against the tide with respect to the way most people write Android applications. So yes, I am not a big fan of the Android abstractions for structured data storage, but unfortunately that's kind of the way things work. So the goal should be to make it as painless as possible. We've actually got really cool frameworks for abstracting all of these details, and we might show some of them later. They turn everything basically into like commands and abstract factories, and it all just magically becomes very easy to use. But we didn't want to teach too much special purpose data access mechanisms in this MOOC because people would then complain and say, oh gosh, you're not really teaching us how to program Android. So I'm very sensitive to that. Let's see. where is the character or characters value appended to the URI? So if you take a look, you'll see that those values actually aren't appended. They're discerned by the URI matcher, which looks at the URI that's passed in and checks to see whether or not it's got an ID at the end or not. And if it has an ID at the end, then it's a character because it's identifying a specific row in the table. If it doesn't have an ID at the end, then it's a characters and it's identifying the whole table. We'll see this in a second when we look at the other example. I believe there's a way to interact with the content provider through intents. Not really sure what you mean by that, so maybe you can post some examples on the website or on the discussion forums. Okay, Monty points out, I've asked the Coursera folks to whitelist Java and zip files. For some reason that escapes my understanding, every time a new course starts up, you have to explicitly request the use of .zip and .java files. I've given that request, and it's up to the Coursera folks to grant that request. So it might take a day or two for them to do that, but don't worry, it'll be there certainly well before the deadline. Sorry about that, it's just kind of frustrating. Let's see. So I think that's about it. There was another question that seems to have disappeared. I don't know what happened to it. That said the source code is getting more difficult to understand. Well, yes and no, right? So we're building on abstractions we began to build in the earlier MOOCs, and things like the generic activity and so on, and a particular form of writing these applications. I could just show naked Android code. We could certainly do that. I go back and forth on this one a lot because I understand why people also want to know how to program the Android APIs directly. But after thinking about it, there's all kinds of places you can go on the web and get a tutorial that'll show you how to do naked programming with just the Android APIs. And the problem with those things is that they give you very reductionistic perspectives on how to actually build useful applications with the Android features. And so people end up writing unbelievably hideous code that uses those naked APIs, and then their applications are very brittle with respect to all the other stuff that actually matters in practice, like handling rotations or dealing with concurrency properly. And one of the things you discover about Android is there are an innumerable number of subtle and pernicious topics and features that don't have obvious, consistent ways of being handled if you just program to the naked APIs. So we're also kind of throwing a little value-added capability here with these patterns and frameworks and so on, because I feel very strongly that just learning the naked APIs is not really what these courses are about. The courses are about more than that. You can always go and take the look at other stuff on the web. The Udacity courses will show you how to do naked API programming, but this course is really trying to do something more. So I know it's a little bit of extra work to think these things through, but the good news is once you understand these abstractions, and they're actually pretty simple to use, all the examples are very concise, they're very short, they should all work correctly with respect to all these subtle issues like runtime configuration changes and so on. And so hopefully you've also got some good techniques that you can use when you write your application. Because what we're really trying to do here is we're trying to produce people who are not just code monkeys, not just people who sling out half-baked code that barely works or is full of bugs. We want people who really understand how to think architecturally about how to build robust software. And that process is a never-ending process. It goes on and on and on. Okay, so that is the end of that example. Now what I'm going to do is I'm going to talk through the programming assignment. Let's go find that code. All right, so the programming assignment shells are here. And of course, you can download them. This is all up on the website now. Let's take a quick look at the manifest file. We have an acronym activity, and we have an acronym provider, and then we also have a broadcast receiver called delete cache receiver. We'll talk about that in just a second. Okay, this example, and you can read about it here, it'll tell you what the goal of this stuff is. It's basically taking the acronym application example that we covered in the previous MOOC, and it's redoing it to demonstrate the use of retrofit and Android content providers and SQLite databases. That's basically what it's doing. It's giving you a chance to play around with these features using more or less the same user interface, more or less the same functionality that we had done in the previous solution. The previous solution, if you go back and you look at the previous solution, which is also on the web for those of you who weren't in the previous course, if you go over here and you look at acronym application retained, you'll find the earlier solution. That's under the post of 15 GitHub repository that's on my GitHub link. And that basically used a bound service, a pair of bound services, and it did a lot of JSON parsing manually and used AIDL and all kinds of good stuff. So it was pretty cool, but we wanted to have a different version that used retrofit and some other features. Here's a quick overview of the application. It looks like pretty much like the one we had before, just a few minor differences. There's an acronym activity, that's almost identical. Operations are a little different, of course. There's no services. Instead of services, we have providers. And we use retrofit to actually do the call to the web service. And we have utils, which have a whole bunch of stuff in them that we'll talk about. Okay, so that's kind of the big picture view. So let's talk quickly about activity. I'm not going to spend a lot of time on this because I want to focus on the database part. But basically, the acronym activity is a generic activity, just like everything else. It's got a edit text to enter the acronym by the user. It's got a list view that'll display the results. It's got an adapter that will provide the acronym expansions. These are all identical to what we had before. Here's the onCreate hook method. It initializes the fields, sets the adapter, calls up the generic activity framework, giving it the acronym ops class as the operation object that it's going to manage. It has a single expand acronym method. We're not trying to do different kinds of AIDL interfaces and services this time. When you type this, when you click the expand acronym button, it goes out and it gets the acronym and it makes it uppercase. Make sure it's not empty, and then goes ahead and calls into the ops object to expand the acronym. And when the expansion succeeds or fails, display results gets called back, which either posts a toast if things go wrong, or if everything goes right, it goes ahead and displays the acronym expansions in the list view. And this is just a way to reset the display every time so we don't see the old values when you give a new one. All right, that's the activity. Not much different. That's pretty much identical to what we had before. Here's acronym ops. This is a little different from what we had before for a couple reasons. First, it uses the generic activity framework. It also uses the generic async task framework. You'll see how that gets used in a second. We define ourselves a weak reference, like always. We keep track of a list of results to display, if any. And here's where things start to diverge. We now have something called a content provider timeout cache. And what we're doing here is after we, whenever we go to get an acronym expansion, the first thing we're going to do is we're going to go look and see if the expansion is already in the cache. If the expansion is in the cache, we're going to return the expansion, and we don't have to make a web service call at all. If the expansion is not in the cache, we make a web services call using retrofit. We get the results, and we store them in the cache. So that's basically how the cache works. And the cache, of course, uses a content provider and an SQLite database. Here is the service proxy for accessing the retrofit. This is a retrofit proxy for accessing the web service. We'll see how that works in a second. That's part of what you have to implement. Here's the generic async task. And the the generic async task allows us to run the async task in the background, but not have to break up our nice little class. You'll see how that gets worked in a second. Here's the public constructor. We need that for the generic activity framework. Here's the onConfiguration hook method, which basically sets the weak reference. If this is the first time in, we initialize the cache. And then here, for what you need to do for your assignment, you need to replace this null with the call to the retrofit libraries to make the proxy that's going to be able to talk to the web service, the acronym web service. And as you'll see, this is crazy code. If you take a look at the weather service provider example, you'll see an example of how to do this crazy code. It's also talked about, of course, in Professor White's videos. If this is not the first time in, we update the results display if there were any results that have to be redisplayed. Here's the expand acronym call. There's all kinds of ways to do this. Because we have an async task here to run the call in a background thread, if you click expand acronym and there's already an async task that's running, we cancel the existing async task, make a new one, and re-execute it. That's not the only way to do things. I was just having fun with canceling async tasks, just to illustrate how you can cancel async tasks. You execute the async task, that causes the do in background method to be run. Because we're using our cool little generic async task framework, do in background method actually can run in this class context, which is a little cleaner. And here's what we do. We try to get the expansion of the acronym from the cache. If that doesn't work, or sorry, if that does work, then we're done. We return the results from the cache. If it doesn't work, then we go ahead and make the RPC call using retrofit. And you have to go ahead and fill in how that retrofit call is going to work here. And once you do that, then you take the result, you get the long forms of the acronym, you stick those long forms into the cache, and you go ahead and you return the long forms back to the caller. When that call is done, that will pass this back to the onPostExecute hook method, which updates the results and displays the results and indicates that the async task is finished. So that's basically the client side. There's only a couple of to-dos here. If you take a look, you can see that you have to create the proxy for the retrofit access, and then you have to write the code to access the web service using retrofit. All right, speaking of retrofit, let's go look at retrofit. That's right here. Here's the interface. I provided you the interface this time. For the third programming assignment, you'll have to write a whole thing from scratch, but this is a good model to use. Here is the retrofit method. Basically, retrofit works by annotating or annotating code and then reading those annotations. We have the endpoint, which is where the web service is located. We have the query parameter that we're going to pass in here, which is SF for short form. And then down here, we define the method called getAcronymResults, which returns a list of acronym data. And it takes in the short form of the acronym, like TCP or Corba or BBC or whatever the short form is. And these annotations are used by retrofit to say append SF here as part of the query. And this is also another piece of the puzzle that has to be passed in. This is basically how you build up, this is how the annotations you use to tell retrofit how to make the appropriate HTTP get or post request to do the request over to the server. Now, this all is premised on the fact that there's something called acronym data, which is essentially a POJO or a plain old Java object. And here's the really cool part of retrofit. If the JSON tags that come back have the same names as the fields in your POJO that you express, like here, then retrofit can automatically figure out how to do the mapping. So SF, LSF, and so on, these are actually the names of JSON tags, and retrofit can use reflection in order to figure this out. So you don't have to really do anything except define how the POJO works. So here's some of the POJO elements. We can set the acronym data. We have getters and setters to set the fields. We have something called an acronym expansion, which is basically the long form of the acronym, and the frequency, how often it's appeared in print, and when it was originally designed. So that's an acronym expansion. We have getters and setters for that. And then, as you might expect, we have a list of acronym expansions. So this is basically just the data structure that's describing a POJO that maps onto the JSON data that's sent back from the acronym web server. So the cool part is that Retrofit does all of this crazy parsing for you. And for those of you who implemented the weather service from the previous MOOC, you will appreciate what an improvement this retrofit mechanism is relative to having to write those JSON parsers manually, which was just unbelievably convoluted and horrible. So I gave you the bulk of this code. I think I gave it all to you, but you'll have to learn how this works so you can do it for the third assignment. Let's take a look at provider. Provider is where all the interesting stuff happens. So let's spend the time on that. As before, we have a contract file, acronym contract, where we define a content authority, which in this case is Vandy MOOC acronym. We define a base content URI, which basically appends content authority to the content / scheme. We have a path acronym where we can use to name the table or access the table name. We have an acronym entry, which implements the base columns interface. And as you can see here, we define the content URI, which essentially concatenates the base content URI with the path acronym. So now we have a way to identify the acronym table. We define our MIME types, content items, and content item, which indicate the entire table or just a single row in the table. Here's our table name field, which we used up here to make the to indicate the path acronym. We then go ahead and define various columns. We have the acronym column, the long form, the frequency, since, and something else called expiration time. Acronym is obviously the acronym that we gave as the user. Long form, frequency, and since are what comes back from the that's what comes back from the acronym service. And expiration time is something that we added in order to be able to basically clean up the cache on the basis of time. And you'll see how that works in just a minute. Here's the build acronym URI method. You give it an ID, and it gives you back a URI that has the content URI with the ID appended at the end. All right, so that's basically the contract. You notice if you go back and look at the Hobbit example we looked at before, it's almost identical in terms of what goes in here, the naming, the strategy, and so on. Here's something called acronym database helper. We didn't have this in our previous example because we didn't use SQL, but this is a very canonical way of doing things in Android. You have this base class called SQLite Open Helper, and so we make ourselves a database helper that extends that. And this is basically used for several things. This is where you define how you handle versioning of the database. It's where you actually define the name of the database that's going to be stored on the device. We call ours acronym DB. We also identify where we want the storage for this to go. And in our case, we're going to put this in something called the cache directory, which is a special directory that Android defines that is managed in the sense that if you start running low on, if the device starts running low on memory, Android will automatically clean up things in the cache directory. So that's a good place to put a cache. So we put in the cache directory location and the database name and the version. Here's the onCreate method. This is what actually creates, or this is what defines the table and then creates the table. You can kind of read this as though you're defining a data structure. So here's an SQL string that creates the acronym table. We create the table with this name, and the table is going to have a primary key, which is an integer. It's going to have the acronym column, which is a string that can't be empty. That's like BBC or TCP. It has the long form, which is the text that would be the expansion of the acronym. It has the frequency. It has the time when the acronym was first defined. And then it also has the column expiration time, which is going to keep track of how long this entry is considered to be live until it becomes stale. So that's how we create the table. That's the string, and then we go ahead and we execute this SQL statement on the database, and that goes ahead and creates the table. You'll notice that we pass the database in to this table, to this method. When you update things, if you update the table and you change the schema, then you need to drop the old table and create the new one. That's the helper, and you'll see how this works in a second when we look at the content provider. Here's the actual content provider itself. This is where all the bulk of the heavy lifting is done to store the expanded acronyms. By the way, there are all kinds of ways to implement this. We chose a particular way here because we wanted to illustrate some key ideas in SQLite, but you would not have to do it the way we do it. This is just the way we chose to do it to give you more interesting SQLite operations to implement. We have a tag, which is the used for the debugging. We have our acronym database helper with open helper. Going to use that whenever we need to get access to the database. Here's where we keep track of whether we have one acronym being accessed in a URI or the entire acronym table accessed. Just like before, we build the URI matcher. The URI matcher looks almost identical as before. We go ahead and we make a matcher element for this particular content provider with this table name, with the acronyms, the plural key versus the acronym singular key. Notice that this has the funny symbol that says this is what you use if you have a URI with an identifier at the end, as opposed to just being a path. So that's how we're going to match things. Here's the onCreate method. The onCreate method goes ahead and makes a new acronym database helper, passing in the context of the call, and then we go ahead and store this in a helper variable that gets used all over the place. Here's the getType method that returns the appropriate MIME type, depending on whether it's multiple or single entries we're looking for. And now we get into the fun part. Let's see. Probably want to put insert first. Let me rearrange this just a tad. We don't actually use insert in the code. We always use bulk insert, but we have you implement insert just so that you can learn how to do it. Here's what we do. We come along in the insert method. We extract out the SQLite database from the database helper. And since we're inserting, we have to get the database for writing. We figure out if we're trying to have a URI that puts things into the table or into one element. In this case, we only support inserting something into the table. If you want to update a single element, you should use update, not insert. And then down here, you have to write the code that actually goes ahead and inserts the content values into the SQLite database. And as I said before, we'll talk about SQLite next week on Monday. And if you want to get a head start on this, you can go look at the weather service provider example, which illustrates how to do this for weather service, not for acronyms, of course. So you'll have to fill in this code. If it succeeds, if you insert something, then you go ahead and you build an acronym URI, and that's going to get returned as the result of this particular method. And of course, you notify any observers that a row was inserted. That's insert. Here is bulk insert. Bulk insert is much like insert, except it begins a transaction and ends the transaction in a finally block. And then in here, you have to write the code that'll insert all the content values that are passed in this array of content values into the table. And I recommend making the call directly on the database table. Do not call the insert method. That would be additional overhead you wouldn't need to use. Don't call the content provider insert. Call the SQLite database insert method to do that. So you have to figure out how to insert things. Here's the query method. Here you're going to have to write the code to do a query for querying things in the entire table or querying for a particular entry in the table. and I provided you a little bit of the code here to get the row ID in this case. What you do in that case is you create a selection criteria that looks for the ID that matches the ID that's part of the URI. And so you'll have to write the code to do queries. And update, again, much the same thing. You have to write the code that does the updates. And in this case, we're only updating the entire table, not an individual row, although I suppose you could add updating an individual row. That would be pretty easy to do. And then here's the code for delete. You have to write the code that deletes an element. And of course, you have to make sure you pass in the right selection and selection args. And we'll talk more about that when we talk about SQLite. Basically, what you're doing here is you're filling in the calls in the content provider to do the SQLite operations, which we'll talk about on Monday. And if you take a look at the assignment, it also gives some links to more information about SQLite and content providers with videos you can watch. All right, that is the content provider. Now, the last piece of the puzzle here is really the fun part. This is the part that does the timeout mechanism. This is the timeout cache. So we actually implement the same interface we did for the acronym application retained example, and also from the weather service assignment that you did last time. I have a timeout cache where you can put and get fields and time them out and so on. So that's basically the interface. Here is the implementation, some of which is completed, some of which you have to fill in. So this is a timeout cache that actually caches the data in the content provider using SQLite. Now, of course, that's a little bit insane. You probably would not normally use SQLite as a cache. So we're doing this primarily just so you get experience with SQLite operations in a scenario that's familiar to those of you who took the previous MOOC and saw how we used the concurrent hash map to implement a non-persistent cache. So what we're doing here is we're actually implementing a persistent cache, which maybe is overkill, maybe not, all depends on what you think your use case is. But again, the point here is not to try to write a professional grade acronym application. It's to teach you the concepts of being able to use SQLite to do various kinds of things. So content provider timeout cache is a timeout cache that's mapping strings, which are the acronyms, to a list of acronym expansions. Here is the way this is going to work. We are going to have an alarm wake up every half a day and clean out all the entries in the cache that are stale. So entries that are not accessed more than once will get cleaned out every half day. So that this shows how to use an alarm manager to do some cool stuff. We also keep track of the default time after which data entered into the cache is considered to have expired and is stale. Here's the alarm manager. This actually doesn't need to be static. Change that. Here's the constructor. We go ahead and store the context for the default timeout, get the alarm manager, and schedule the cache to be cleaned up. We'll look at this later. That's kind of secondary to what I want to show you. That code is all provided for you. Here's the get method. So you call get. If you recall, get is actually invoked up here in operations, where we try to get the result from the cache when we are expanding an acronym. So we first check to see if the cache has the item. We come in here and we create selection criteria to look up in the table for the acronym column, and we give the acronym name as the selection args. And then we go ahead and we query the table. So we give the content URI for the table, and we give the selection criteria and the selection args. Now, notice we do this in a try with resources block so that this cursor will be closed automatically when we're done. So assuming that we don't get anything, if there's nothing in there that matches, we return null. There was no cached entry. If we do find an entry in the table, we have to check to see whether the entry has expired or not. And so what you need to do here is you need to figure out how to compute the expiration time, and then you go ahead, and that's based on the information in the cursor. So you have to use the cursor information to figure out whether or not the expiration has expired, and you do that by looking up the field to find out what the result is. So, or the column rather. So if the acronym has indeed expired, if the expansion has expired, remove it. And the way we're going to do this to avoid holding up the user is we're going to spawn a background thread, which when run will remove the acronym from the table. And that's a perfectly fine thing to do because these calls are made thread safe by SQLite. Otherwise, if it is not expired, then what we do is we go through the cursor and we extract out all the information that's stored in the cursor related to the expanded acronym. And the way the table is laid out, we have a separate row for every expanded long form of the acronym. That's not the only way to do the table. We just did this so we could do some more interesting SQLite queries and so on. So you go ahead and call this get acronym expansion helper method with the cursor, and that gives you back an expanded element that's an acronym expansion from the cursor, and you just build up this list of these things and return that from the function. Here is the get acronym expansion method. You have to write the code that looks in the cursor and goes ahead and extracts out the entries that you need here. So you're going to need to get the long form, the frequency, and the since, which of course are columns. And those things then get stored here. And then you make a new acronym expansion, and that gets returned from the function. So you have to fill those things in. Now we have put. There are two put methods, one that puts with a default timeout, one that puts with a user-specified timeout. Both methods call put values. Put values will store an acronym and its expansions in the table for a certain amount of time. Obviously, if people give you input that's empty, we fail because it doesn't work. If they don't, then we go ahead and figure out what the expiration time is, which is basically the timeout period from now in nanoseconds. And then we go ahead and we're going to do a bulk insert, and we're going to basically walk through all the elements in the long form here, and we're going to insert these things into the content value array, content values array. We're going to go ahead and crack open each element and insert it, including the name, the long form, the since, the frequency, and the expiration time. Those will all get put into each content values entry and stored in the array. And then when we're all done, we do a bulk insert of all those things into the database. So we're basically storing the acronym expansions in the database. That's what we're doing when you call a put. Then there's just a couple more things you have to implement. You have to implement the remove method, which is going to remove an individual acronym and all the rows associated with it. Keep in mind that an acronym can have multiple rows, and so here you're going to have to do a call to do a delete that works on the rows, because there may be multiple rows. So you have to write the right selection field to do that, selection clause. And so that's how you're going to go ahead and remove an acronym and all of its rows from the table. Here's how you compute the size of the table. And then the final thing is to remove all expired acronyms. And so you're going to have to write the code here that figures out how to expire all acronyms, or remove all acronyms whose timeouts have expired. So you'll have to do a delete with the appropriate query to do that, or appropriate where clause to do that. A couple more things just to round this out. Here's how you schedule the cache cleanup that runs periodically, every half day. If the alarm is not currently active, we go ahead and create an alarm using this thing called the delete cache receiver. And there's a delete cache receiver, which is basically a broadcast receiver. And we use something called a pending intent, which was covered in Professor Porter's MOOC. And basically, this is a broadcast intent that's created. And what happens is this thing gets registered to run at some point in the future, say 12 hours from now. And that will then wake up periodically every half a day, and it will end up calling back on the on receive method here. And so when the on receive method gets called, you have to write the code to call the appropriate method in content provider timeout cache to expire or remove all the expired timers. Okay, so that's basically an overview of the whole shells. As you can see, it's a fairly long piece of code, but the actual amount of stuff that you have to fill in is fairly limited. I think there's 4 files you have to actually do something to. The retrofit stuff should be a piece of cake. That's just there for you to learn how to use retrofit very quickly. The bulk of the interesting stuff is really in the content provider and the cache. Okay, so let's go ahead and take a look at some questions. Question 1, is the video going to have subtitles in Spanish? I have absolutely no idea. I don't handle that. That's a good question to ask the Coursera folks. You might want to post a message to their technical support. I can guarantee you that any Spanish subtitles will not be something I do because I don't speak Spanish, unfortunately. Let's see. Regarding the next iteration of the concurrency MOOC, would you add a topic about Android animation using Surface View, which requires a subtle thread model implementation in order to do it correctly? So I'm not really a GUI person. That would be a good question actually to ask Professor Porter, because he's the one who covers the GUI mechanisms in his MOOCs. So you might want to join up in his MOOC and ask him whether he could cover that. That'd be a great topic. He spends a little bit of time on concurrency in his MOOC, not nearly as much as we cover, of course, but he covers some. Let's see, there's also a question. I've watched the last lecture and I have a question. It's about the generic framework. I was reading the MVP pattern with Android, and there are a few good frameworks that people did. Is generic framework an MVP? I'm actually not familiar with MVP. Firas, why don't you go ahead and post any link you might have to MVP as a concept and some of the frameworks there, and I'll be happy to take a look and see if it's similar. I wouldn't at all be surprised if someone else had come up with the same idea. It's a pretty obvious idea after you get sick of writing the code to handle screen rotations over and over and over again. It gets very tedious and error prone to do that. So I wouldn't at all be surprised if people created their own environments for doing that. I made my own and put it in here just to try to avoid dependencies on third-party code in the solutions. Okay, well, it looks like we have gone through the bulk of the questions. As always, I will go ahead and render all this stuff out here as soon as possible. Very happy to say that the Coursera folks got the downloaded videos up fairly quickly. Hopefully the subtitles are not too far behind. I uploaded all the slides from Wednesday's lecture. That should all be up on the website. And the last thing I need to do today, it's just been a matter of triaging things, is get the quiz put up. So I will try to get the quiz up later today. Don't worry about the quiz deadlines. All the deadlines for quizzes are at the very end of the class on the final day of the class of the MOOC. You'll have to turn the quizzes in, so you can do them at any time. Okay, well, thank you all very much for joining, and I look forward to talking to you soon.